Ігор Тодор, біологічна активність та безпека наноматеріалів, що можуть бути використані при створенні векторних систем протипухлинних препаратів. Please, Ігор.
Yeah, nanomaterials which could be used in development of vector systems of anti-drugs. Dear colleagues, at the current level of development, science and techniques, much attention is paid to nanotechnologies. The materials with nanotechnologies are widely used in different areas of activity, including medicine, but how the nanoparticle nanomaterials have properties that drastically differ from their counterparts in the microscopic dispersion in suspensions. They are principally new, and the factor that can influence the organism, environment, and the human body. So, due to small particles up to 100 nanometers, nanoparticles, and always detected by the protective system of the organism. Yeah, they're slow to the vessel, which leads to their accumulation in the human body. Therefore, the method of detecting risks of possible negative impact on nanomaterials on the human body and organization of safety measures is the most vibrant problems of today. Our institute here is pioneering in developing and studying the biological effects mechanisms of metal-containing nanomaterials of different origin, and in addition, there are all developments that we would love to underline the algorithms and estimate the safety level of the nanomaterials for creating a vector system, anti-tumor drugs. Since there is a lack of the general state national materials or the concerning the safety of nanomaterials, it requires verified and designed approaches to the process of estimating toxic effect of nanomaterials on biological objects. The available safety methods are aimed at mainly on appraising the toxicity in vitro, both in vitro and in vivo, but specific properties of the particles that can influence the development of the toxical effects are considered. So before we study the toxicity of nanoparticles, one should define the factors. They determine the toxicity of such materials. A small. First of all, is a small size. Large, high relative surface properties, facilitation of penetration of other contaminants inside the cell, accumulation in the environment. Apart from studies of the toxicity of nanomaterials, logical processes in which particles are used should also be investigated. So it means the cellular uptake of nanoparticles, the intracellular transport and accumulation, oxidative stress, and resulting damage of cell organelles. And also development of inflammatory processes. So therefore, the the goal is to define centrifugal detection of nanomaterial safety. Research extras both in vivo and in vitro. So determine the complex of psychological, material, structural, and biochemical indices which demonstrate cytolytic effect studied nanomaterials on cells in vitro and methods which could require safety in the use and development of vector system of drugs. In this regard, the following task has to be performed. It's tomographical detection of nanomaterial safety, then the analysis of genotoxic effects on nanomaterials by a micronucleus test and DNA calm assay. And later, evaluation of cell membrane status, lipids ratio, mitochondrial membrane potential, and also detection of oxidative stress manifestation. It's Rhodgen ratio, luminol dependent chemiluminescence evaluation of sulfhydryl groups content. First of all, the objects of our studies, the cells and MCCs of breast cancer cells, are both resistant to anti-tumor drugs as doxorubicin and cisplatin, and also the early exotic carcinoma cells. We studied the ferrum 304. The narrow size of the particle was 40 up to 5 nanometers of colloidal gold. During the first testing, the express testing for cytotoxicity, we conducted cytomological detection of safety. As you may see from the upper images, we recorded the accumulation of nanomaterials inside the cell. And we observed how these materials impact the very look of the cell, its status. It was recorded by the nucleus fermentation and blebing and concentration of chromosomes. So based on this morphological studies, we developed a method of light optic visualization for magnetics, and also the method of verification cytotoxicity effect on a tumor cell. However, if this express method is express testing conducted, we can purely sort of morphological studies, but for the complete correct estimation of the impact of nanoparticles on the human body and organisms, conducted some other studies. The great, more comprehensive analysis of such effects. Firstly, we use the methods that allow to estimate genetic system of nanoparticles, how such particles, if of magnet fluid and the colloidal gold, how they impact the cell and the genetical effect. We use the DNA COMAT method. It establishes the percentage of DNA in the comet tail. Also use the micronuclear test. We count the number of micronuclei. You can estimate the look of the cells after be exposed to nanoparticle. So using this cytofluorometry. Cytofluorometry, we also studied the impact of nanoparticles of the magnetic field on the colloidal gold, both on this cellular cycle and number of cells that are either in the stage of apoptosis or necrosis. After that, after studying such impacts on the cell cycle, we evaluated the effect on this status on cell membranes. We used a method. We studied the condition of mitochondrial membranes using fluorescence, JC1, staining. In fact, this potential is characterizes the functional activity of mitochondria. The second approach is to study the number of lipids, both in plasmatic membrane and in granule membrane, number of lipids, general lipids, and phospholipids. So we studied the change in lipid profile. When nanoparticles penetrate inside the cell, we start the metal-containing nanoparticles. So in one way or another would impact the pro-oxidant or antioxidant balance. We suggested the study number of oxidation peroxide compounds after the using the chemiluminescence method, and after using the flow using the method fluid color photocytometry. We studied the sulfate rate groups that directly participate in eliminating the active forms of oxygens. So using this variety of methods, we developed methodology of evaluating the safety of nanomaterials. So we created the algorithm of testing nanovector systems. And the suggested algorithm allows to screen metal-containing nanomaterials, taking into consideration the interaction with the membranes and organelles of normal and tumor cells. So the unique approach allows to obtain the first information about the biological activity and potential safety of materials that are supposed to be used in vector anti-tumor drugs. So in fact, the slide shows the algorithm we suggest or printed. So it allows to evaluate using the both express method, cytomorphological studies, and more detailed and more in-depth study. With this algorithm, using the toxicity estimation method as the spectrum of biological, biochemical, and biophysical criteria of evaluation of nanomaterial safety that allows to get up-to-date information about the toxicity and the impact on the functional activity of both normal and tumor cells. Use of this about for the accumulation after use of the metal-containing biological strategies, economically profitable and cheap. This is a field of application suitable for broader spectrum scientists, medics, and biologists, and also for the pharmacologists who are involved in development and production of nanosystems for use in medicine and particularly in oncology. I'd like to emphasize that we developed methodology for evaluation of biological safety of nanomaterials and algorithm for testing nanovector systems. So in future, this algorithm allows to perform screening of metal containing materials according to features of their interaction with normal and tumor cell membranes and organelles. So it helps to identify nanomaterials and nanoparticles that could be used in any branch of economy. Thank you, Nanotechnology. Dear colleagues, up to 2 questions at most, because we're late. My answer is that before we suggest something to use, work in the medicine or biology or in any field of economy, we created this algorithm. So prior to using any material, any nanomaterial for treatment purposes, so before the nanoparticles are used for treatment or developing new drugs, so it's a mandatory requirement that such algorithm should be used to determine what type of toxicity or another nanocompound possesses. And now after that, you can study you can proceed to experimental tests. Experiments are tested on animals, and after toxicology data are positive, negative, then you can proceed to another further steps of testing steps. Thank you. So I encourage for brief questions and brief answers. I would like to comment your question that there were brilliant reports on the about the nanomaterials, nanoparticles, and their usage in our life, but we never consider the influence of the implication in our life. Now that each year the oncopathology rate is increasing by 1 to 2% annually. So when you offer nanomaterials in any field of economy, both in medicine, techniques, so we need to test and see what we obtain when we use nanomaterials. Okay, Nicholas, thank you very much.